Dear students, in the last class we have studied some preparations of alcohol and the physical properties of alcohols. Now we'll go on chemical properties of alcohols. Nothing but when we study some properties whose chemical change, that means change in the chemical composition of the compounds are observed, such properties are called as what? Chemical properties, and we are going to study that. Why alcohol shows some chemical reactions? Because they act as both nucleophiles as well as what? Electrophiles. The bond between, because we know alcohols contain OH, when the bond between oxygen and hydrogen, that is OH bond, is broken, then alcohol react as nucleophiles. That means the bond between OH is broken when alcohols react as nucleophiles. You can see the alcohol, general formula of alcohol, carbon, oxygen and hydrogen. When the bond breaks, that means OH bond breaks, when this OH bond breaks, then alcohol react as what? Nucleophiles. In another case, the bond between CO, that means carbon and oxygen, is broken when they react as nucleophile. That means when alcohol act as electrophiles, then CO bond is broken. When alcohols act as or react as nucleophile, then OH bond is broken. We just observe here. CO bond is broken. When carbon oxygen bond is broken, then alcohol act as electrophiles. When OH bond is broken, then alcohol act as nucleophiles, and that is why they react with the other compounds. Then alcohol acts in nucleophiles. Say oxygen containing the lone pair of electron that attacks carbocation and intermediate is formed, then the OH bond is broken, liberating what? H plus. That's why you can say here OH bond is broken. OH bond is broken and alcohols act as a what? Nucleophile. Alcohol act as a nucleophile. Another case, protonated alcohol act as electrophiles. Here alcohol we have, when it gains a proton, then lone pair of electron which accepts this proton and becomes what? OH2. Now since it gains a proton and here it behaves as what? Electrophiles. Electrophiles. Say Br minus attacks to CH2 and this loss of water molecule takes place. Hence here, since Br minus is nucleophile, therefore alcohol behave as what? Electrophiles. Hence alcohol react as both electrophiles as well as what? Nucleophiles. Both electrophiles as well as nucleophiles. We'll go one by one. First, we can go for reactions involving cleavage of OH bond. That means the reactions due to breaking of OH bond. That means alcohols act as nucleophiles. First one, acidity of alcohols and phenols. Why they are acid in nature? That means alcohol behave as acids. Why they are acids is the theory going to study here. When alcohols react with the metals like sodium, potassium, aluminum, etc., to give corresponding alkoxides. That means if alcohol, then they give alkoxide. If phenol, they give phenoxide with the liberation of hydrogen gas. With the liberation of hydrogen gas, that indicates the alcohol behave as an acid, because we know metals behave as base. Since alcohol reacts with metal, therefore alcohols act as an acid. For example, against general formula, ROH, alcohol, reacts with metal like sodium, which converts into sodium alkoxide. Sodium alkoxide, RONA, with the liberation of hydrogen gas. Indicates that alcohol readily reacts with the metal. Here, sodium metal acts as a base. Therefore, this alcohol acts as an acid. Alcohol acts as an acid. Another example, when you can consider tertiary butyl alcohol reacts with the aluminium, reacts with the aluminium metal, which converts into tertiary aluminium tertiary butoxide, aluminium tertiary butoxide with the liberation of hydrogen gas. From these two reactions we can say alcohols behave as an acid. Alcohols behave as an acid since they readily react with the metals. Another phenols. When phenol reacts with the metals like sodium or potassium, which converts into sodium phenoxide. Here the metal is there, sodium, and this is phenoxide, therefore which results in what? Sodium phenoxide with the liberation of what? Hydrogen gas. Hence, it's very clear phenols also behave as an acid. From these reactions, it's very clear both alcohols and phenols they act as an acid. Why? Now the question is, this react with the metal. That's why they are acid. Why? What is the uh, nature? Why alcohols behave particularly as an acid? Thing is, alcohols they show acidic character because the polarity or the polar nature of OH bond. Here OH bond, which is there is a polarity is produced. Oxygen is more electronegative, hydrogen is less compared to oxygen. So the distribution of the bond pair of electron towards oxygen. So oxygen carries partial negative charge, hydrogen carries partial positive charge. Hence we can say they are polar in nature. Due to the polarity, due to the polarity, this reacts very faster with the water. Say when alcohol, when they lose their proton, it becomes what? RO minus. When it reacts with water, here water acts as an what? Acid. Since it is a nucleophile, it acts as a base. And we will get what? Alcohol. It's a conjugate acid, and OH is conjugate base. This reaction shows that water is a better proton donor. Why? Because we know RO minus, which readily gains a proton. Since it gains a proton, it acts as a base. And water, which loses the proton, therefore it is an acid. Since it is a base, that is RO minus, alkoxide is base, its conjugate is always acid. That means ROH behaves as what? Acid. Also in the above reaction, we note that alkoxide ion is a better proton acceptor than hydroxide ion, which suggests that alkoxides are stronger bases. Alkoxides are stronger bases. Since they are stronger base, its conjugation is always acid. Therefore, they are conjugate acid. Alcohol is conjugate acid. Therefore, alcohols act as a Bronsted bases as well. Bronsted theory. It is due to the presence of unshared electron pairs on oxygen, which makes them proton acceptor. Which makes them proton acceptor. Now the thing, acidity. Once we know that alcohols are acidic in nature, certain groups are attached to the alcohol, that means R. If we take the general formula ROH, OH decides the acidic character, but that R plays the major role in its acidic nature. That means whether the alcohol is more stronger acid or less stronger acid, that's what decided by the group, what type of group that alcohol has. If electron donating group such as CH3, C2H5, etc., that increases the electron density over oxygen, because these are electron donor. When they attach it to OH, they donate the electron density to oxygen. Then the polarity of OH decreases. Since oxygen gains more electron density from its donors, automatically the OH bond becomes what? Less polar, then the acidic character goes on decreases. Acidic character decreases. On the other hand, if electron withdrawing groups are present, such as NO2, X, etc. present, they withdraws the electron density from oxygen. Electron withdrawing groups withdraws electron density from oxygen, then the polarity of OH is increases, so acidic character also increases. Students, do remember, if electron donor groups are present, then the acidic strength of alcohol decreases because decrease in the polarity of OH. If electron withdrawing groups are present, then the acidic character increases due to increase in the polarity of OH. Then we can go for some example. For example, say RCH2OH, where R is electron donor. Now R is electron donor, such as CH3, C2H5, etc. Since this donates the electron density, electron density over oxygen increases, the polarity decreases, so that becomes what? The acidic. That means less acidic if there is only one R is present. When two R's are present, further polarity decreases. So that is the less acidic when compared to the primary. Hence, primary alcohols are more acidic than secondary, and secondary are more acidic than tertiary. Because in tertiary there are three donors, and in secondary there are two donors, and in primary only one donor. So based on the number of donors attached to OH, the acidic character of the alcohols also varies. Remember, primary alcohols are more acidic than secondary, and the secondary is more acidic than tertiary. Alcohols are, however, weaker acid than water. This can be illustrated by the reaction of water with an alkoxide. That's what explained earlier. When alcohol reacts with water. Now, second reaction, esterification. What is esterification? Name itself says ester, formation of ester. Esterification means formation of ester. How? When alcohol reacts with the carboxylic acid in the presence of acid, in the presence of acid, such as sulfuric acid, are commonly used. When alcohol react with the carboxylic acid, acid chloride, or acid anhydride in the presence of a sulfuric acid or in presence of acid, they result in what? Esters, or esters are formed. See, alcohol or maybe alkyl or aryl group reacts with carboxylic acid. Now RCOH means what? Carboxylic acid in the presence of acid medium such as H2SO4 or some other acid medium, which results in ester. So RCOOR dash. General formula is RCOOR dash with the loss of water. This reaction is called esterification reaction. The reaction with carboxylic acid and acid anhydride is carried out in the presence of small amount of concentrated sulfuric acid. That's what I said here, in the presence of acid. Alcohol reacts with the anhydride. These are called as what? Acid anhydride. RCO twice oxygen anhydrides, acid anhydride in presence of acid like sulfuric acid, which results in ester with the carboxylic acid. Side product is carboxylic acid. The major product is esters are formed. The reaction is reversible, therefore water is removed as soon as formed. That means during the reaction, either water or carboxylic acid, they have to remove continuously since the reaction is reversible. The reaction is reversible. Remember, esterification means reaction of alcohol with either carboxylic acid or anhydrides or acid chlorides in the presence of acid medium such as sulfuric acid. Esters are formed. Esters are formed. With the acid chloride, that means alcohol reacts with the acid chloride. Here, the pyridine is used. Here is what? Pyridine is used instead of constant sulfuric acid. Here, pyridine is used, and HCl is also used to neutralize, and esters are formed. The salicylate product is formed here. When alcohol reacts with chloride, acid chloride, in the presence of pyridine, ester is formed. Ester is formed with the liberation of hydrochloric acid. With the liberation of hydrochloric acid. Remember, it, it shifts the equilibrium to the right hand side. The introduction of acetyl CH3CO group in alcohols or phenols is known as acetylation. Acetylation. Here CH3 is acyl group. If R dash is CH3, then CH3CO is there. Therefore, the process is also called as what? Acetylation. The process is also called acetylation. Acetylation of salicylic acid produces aspirin. Important reaction for examination point. When salicylic acid, that is benzene, is attached with the COH and OH alternative position, then that is called as salicylic acid. When salicylic acid reacts with acetic anhydride, acyl group, it may be acetic anhydride or it may be acyl chloride. CH3CO group must be there. The substitution of CH3CO group takes place in terms of acid medium. Substitution of CH3CO group takes place. This is called acetyl. This is called acetyl, and already we know the group name of this group. This whole group is called what? Salicylic acid. Since it is acetyl, therefore we can call acetyl salicylic acid. Acetyl salicylic acid, and in common it is aspirin. In common it is aspirin. This is the esterification reaction. These are esterification. Remember, esterification reaction. Alcohol reacts with either carboxylic acid or acid anhydride or acyl halides. In the presence of acid medium, they produce esters. They produce ester. For acyl halide, remember pyridine is used instead of sulfuric acid. Now, these are the reactions we have studied so far. That is due to the cleavage of OH bond, breaking of OH bond. Now we'll go for the reaction due to cleavage of CO bond. That means alcohols behave as electrophiles. Alcohol behaves as electrophiles. First one, reaction with hydrogen halide. Alcohol react with hydrogen halides to form alkyl halides. Simple reaction. Alcohol reacts with hydrogen halide. One molecule of water is removed from here. The alkyl halides are formed. Breaking of what? R, ROH here. CO. That's what important. Breaking here, the OH bond breaks here. The RO bond breaks, and hydrogen from here to remove water, and RX is formed. This is mainly used to differentiate, primary, secondary, and tertiary alcohol. That is done by a Lucas test. That is done by Lucas test. Remember, it's a very, very important reaction for examination point. Lucas test. So, what is Lucas reagent? Here, alcohols are dissolved in a Lucas reagent, which gives turbidity. Based on the formation of turbidity, we can differentiate whether the alcohol is primary, secondary, or tertiary. Now the question, what is Lucas reagent? Lucas reagent, it is a mixture of concentrated HCl and zinc chloride. Concentrated HCl and zinc chloride. This anhydrous zinc chloride. This mixture is called as Lucas reagent. When alcohols are added with the Lucas reagent, if turbidity appears immediately, then the alcohols are tertiary. If turbidity appears after 5 minutes, then the alcohols are secondary. If the turbidity appears after heating, then the alcohols are primary. Hence, based on the formation of turbidity, we can differentiate the alcohols, whether alcohols are tertiary, secondary, primary. Tertiary alcohol they give the turbidity immediately when they are added to Lucas reagent. Secondary alcohol they give turbidity after few minutes. Primary alcohol they give turbidity only after heating. Only after heating. Based on the formation of turbidity, it's very easy to differentiate primary, secondary, and tertiary alcohols. Next, one more very important reaction is dehydration. Dehydration. In this reaction, you have to study mechanism of dehydration. In the preparation of alcohols, we studied one mechanism, formation of alcohol from alkenes. Here the dehydration of alcohols to alkenes. These are the two very important mechanisms for examination point. We'll go, what is dehydration? We know the meaning dehydration, nothing but what? Removal of water. Removal of water. To remove water from a compound, we need an agent or a commonly used reagent is concentrated sulfuric acid or phosphoric acid, and catalysts are anhydrous zinc chloride or alumina is used. So that's why when alcohols undergo dehydration, removal of a molecule of water to form alkenes on treating with a protic acid such as concentrated sulfuric acid or phosphoric acid, or catalysts such as anhydrous zinc chloride or alumina. Alcohols, we just observe the formula CH. If we consider the formula COH, when it is treated with concentrated sulfuric acid, one molecule of water is lost. One molecule of water is lost with the formation of what? Alkenes. With the formation of alkene. That's why alcohols undergo dehydration in the presence of acid like concentric acid. Alkenes are formed. Alkenes are formed. Remember, and alcohols undergo dehydration in the presence of concentrated sulfuric acid. Alkenes are formed. For example, ethanol undergoes dehydration by heating with the constant sulfuric acid at 443 Kelvin, which results in ethene, and loss of water. Ethyl alcohol heated in the presence of constant sulfuric acid at 443 Kelvin, ethene is formed. So in the product there is no water molecule. Water molecule is lost. So due to the loss of water molecule, you can say it is dehydration. It is dehydration. Secondary and tertiary alcohol are dehydrated under milder condition. The milder condition. Here, secondary alcohol 85% phosphoric acid at 440 Kelvin, which gives propane. Which gives propane. Then tertiary alcohols you can consider with a condition of 20% phosphoric acid, which undergoes dehydration to give once again propane. 2-methyl propane is formed. That's why both secondary and tertiary alcohols also undergo dehydration, but that is at a very milder condition. But primary alcohols they undergo dehydration with the stronger agents such as sulfuric acid. Thus, relative ease of dehydration of alcohols are in the following order. Tertiary, tertiary is greater than secondary and primary. Tertiary alcohols undergo very easy dehydration than secondary than primary. Now, the mechanism of dehydration of alcohols. In step 1, the formation of protonated alcohol. The alcohol, the lone pair of electrons present on the oxygen, which gains a proton. Proton means from acid. such as we have used sulfuric acid or phosphoric acid, etc., which produces H plus, and that H plus is taken by the lone pair of electrons of oxygen present in alcohol. That's why it is called protonated alcohol. This is called as what? Protonated alcohol. That means alcohols undergo protonation. Alcohols undergo protonation. Protonated alcohol is formed. Next, in the second step, formation of carbocation. That means whatever the protonated alcohol here, the loss of this water molecule takes place in the second step. In the second step, and carbocation is formed. And this is the slowest step, and it is rate determining step. That means rate of the reaction decided by the second step. Here the loss of this water molecule takes place. That means the bond breaks here, and after losing that water molecule, carbon forms positive charge called as what? Carbocation. Hence the second step is called as formation of carbocation after losing water. Now the last, third step, deprotonation to form the alkene. Otherwise, formation of ethene by elimination of proton. This elimination of proton is also called as what? Deprotonation. Hence, deprotonation is the last step to form the ethene. Here, the adjacent carbon atom of carbocation, one proton, which deprotonation takes place, to form ethene. To form ethene. This is the mechanism of the dehydration of alcohol, and very important for the examination. I repeat, first step is formation of protonated alcohol. That means OH group. That means lone pair of oxygen which takes a proton and forms protonated alcohol. In the second step, the elimination of water takes place by forming carbocation. In the last step, the deprotonation takes place to form ethene. Deprotonation takes place to form ethene. Ethene is formed. Next, oxidation reaction. Alcohol undergo oxidation. Alcohol undergo oxidation by breaking both the bonds, which both OH bond and CH bond. In the first two reactions, we studied breaking of OH bond. Next reactions, we studied breaking of CO bond. Now, the breaking of both OH as well as CH bond. The oxidation takes place here. First, breaking of bond breaking, say breaking of CH bond and breaking of OH bond. If both OH and CH bond breaks takes place to give or to go undergo oxidation. While breaking these two bonds, the carbon oxygen becomes what? Double bond. Carbon oxygen becomes double bond by breaking OH as well as by breaking CH bond. That reaction is called as what? Oxidation. That reaction is called oxidation. These are also known as dehydrogenation reaction. Why? Because removal of one hydrogen here, another hydrogen here. So removal of hydrogen is nothing but what? Removal of hydrogen is nothing but dehydrogenation. That's why the reaction is also called as what? Dehydrogenation reaction. Dehydrogenation reaction. Depending on the oxidizing agent used, depending on the oxidizing agent used, a primary alcohol is oxidized to aldehyde, which in turn oxidized to carboxylic acid. The primary alcohol, first step, OH bond breaks and CH bond breaks, which converts into aldehyde. That's what I said. OH bond breaks, CH bond breaks, CO bond becomes double bond. Therefore, this becomes what? Aldehyde. If it undergoes further oxidation, then it converts into what? Acids. Further addition of oxygen takes place to give acid. Carboxylic acid is formed. That depends on the reagent used. Strong oxidizing agents such as potassium permanganate are used for getting carboxylic acid from aldehyde or from alcohols directly. Chromium oxide CrO3 in anhydrous medium is used as oxidizing agent for the isolation of aldehyde. That means we want to separate at this stage only, mild oxidizing agents have to be used such as chromium oxide. Instead, if you use potassium permanganate, which directly converts into what? Alcohols to acid. Remember, because KMnO4 is strong oxidizing agent. If you want to stop the reaction at aldehyde itself, then mildly oxidizing agents have to be used, such as chromium oxide. Students, do remember to convert from alcohols to aldehyde, we have to use mild oxidizing agent. And if we use strong oxidizing agent, then immediately they convert alcohols to aldehyde and then into carboxylic acid. A better reagent for oxidation of primary alcohols to aldehydes in good yield is pyridinium chlorochromate (PCC). The alcohol on oxidation, which converts into what? Aldehyde, which converts into aldehyde. Secondary alcohols are oxidized to ketones because the primary alcohol, one oxygen goes, sorry, one hydrogen from here. So loss of H2 takes place. Remember, this H2 doesn't lose, breaking one OH, H from OH and one H from CH. That's what which results in carbon oxygen double bond and results in aldehyde. If secondary, here also condition same. OH bond has to break here, one hydrogen from here, one hydrogen from C, therefore which results in what? Which results in ketones. Which results in ketones. So what is the condition? If suppose we can take tertiary, what would happen? They do not undergo oxidation because in tertiary alcohol we have no hydrogen at the carbon atom to which OH is attached. Because instead of this hydrogen that would become R dash. Therefore, there is no hydrogen on carbon adjacent to OH. Adjacent to OH. Hence, tertiary alcohols do not undergo oxidation. Do not undergo oxidation. When the vapors of primary or secondary alcohols are passed over heated copper at 573 Kelvin. See, the difference is earlier we are oxidizing by using oxidizing agent. Now we are passing that over what? Heated copper. Dehydrogenation takes place. Dehydrogenation takes place and aldehyde ketone and tertiary are formed by the tertiary. You can see primary alcohol when they are copper, heated over copper, which results in aldehydes because OH breaks, CH breaks. Similarly, secondary which gives what? Ketones. Second alcohol which gives ketones. But earlier case we have studied in oxidation when they are treated with the oxidizing agent, tertiary alcohols they do not undergo oxidation in the presence of oxidizing agent, but when they are passed over heated copper, dehydration, removal of water molecule takes place to give the alkenes. Respective propane is formed.